Feedback is the process of injecting part of the output signal back to the input the process of parts signal, then comparing it with the input. Feedback amplifiers uses this principle. To achieve its objective. So you can have a diagram here. Signal. There are two types of this feedback signal. There's a basic block diagram, and in this case you can see there's an amplifier, and also there is a feedback circuit. And in this case you are taking the output signal, feeding it back to the input in comparison with the input signal, so that at the end of this comparator, produce an error signal that is amplified. So there are basically two types of feedback amplifiers. Roman 1 is a positive feedback amplifier. And Roman 2 is a negative feedback amplifier. Positive feedback. Positive feedback occurs when the signal feedback is in phase with the input signal. When the signal fed back is in phase with the input signal. Therefore, it results in an increase in the amplitude of the output signal. Or it results in an increase in the amplitude of the output signal. So we can now have a sketch of positive feedback. Input signal, VI, negative signal, feedback signal, feedback signal, VF, this is the amplifier, this is the output signal. Output signal. So it requires us to prove that with the positive feedback, there's an increase in amplitude of the output signal. And when you do this, you can now prove using this formula. The output signal is supposed to be the difference in the input signal and the feedback signal multiplied by the gain of the amplifier. When we have this, then we can be able to determine the gain of the amplifier. But when you look at that, the feedback signal is given by a factor beta multiplied by the input signal, by the output signal, given that it's taken from the output signal. Replacing VF in this formula, we shall have VI minus, this is supposed to be a plus beta VO multiplied by the gain. So, by opening the brackets and collecting like times, by opening the brackets and collecting like terms, then we'll have a VO, a VI plus beta VO again. We now connect the like terms together, VO minus beta VO, A is supposed to be A VI. We factorize the output voltage, VO into 1 minus since the gain of the amplifier is given as the ratio of the output signal to the input signal, then we can have our gain being equals to VO or VI. From the expression, you shall have this as A y minus beta A. Since 1 minus the feedback factor times the gain is approximately less than 1, the gain of the amplifier is improved or increased. It's improved or increased. With the negative feedback amplifiers, the signal feedback is out of phase with the input signal. In this case, the signal fed back from the output is out of phase with the input signal. Therefore, this will result in a decreased output. Therefore, this will result in a decreased output with an increased bandwidth. You can have a sketch of the negative feedback. So when you look at this diagram, this is a sketch. The signal being fed back VF is out of phase because it comes at a negative terminal and the input terminal is positive. So the result is that the signal will be against each other and we shall have the expression given us. Our output voltage VO is supposed to be VI minus VF multiplied by the gain of the amplifier. But VF is supposed to be beta VO. Replacing this in this formula, then we shall have our formula as VI minus beta VO multiplied by the gain is supposed to give us the output. We open the brackets, then we shall have VIA minus beta VOA should give us that one. We are now supposed to collect the like terms with the output voltage, and this will result into VO plus beta VOA. It's supposed to be VIA. When the expression is simplified, then our closed loop gain is supposed to be VO over VI. It's supposed to give us A over 1 plus A beta. Where A prime is the closed loop gain, A is the open loop gain, beta is the feedback factor, VO is the output voltage, and VI is the input voltage. So you are required to know and understand what results from both the positive and the negative feedback. They can have advantages of negative feedback. Number one, we have increased stability. This is in the sense that the operation range for the feedback amplifier will be definite. Number two, increased bandwidth. Increased bandwidth. With this, it refers to the fact that the lower limit of the bandwidth will be lowered further, while the upper limit will be increased. You can have a sketch of that. This F1, F2, whereby F1 and F2 are the limits of the operation before the feedback. And F1 and F2 prime are limits after feedback application. Limits after feedback application. 3. Reduces amplitude distortion. From the results of the expression the denominator reduces the amplitude of the amplifier, which results in less heating and amplitude switching distortion. Number 4 is less frequency distortion. Frequency interference and the margins is minimized with increased in bandwidth. Number 5, less phase distortion. And lastly, number 6 is less noise. We can also look at the disadvantages of negative feedback. Number 1, it reduces the gain of the amplifier. It reduces the gain of the amplifier. And number 2, the feedback circuit is an additional circuit. Hence, increasing the cost of production. Have an example. An RC coupled amplifier has a voltage gain of 1,000 with a lower cut-off frequency F1 of 50 Hz, upper cut-off frequency F2 of 200 kilohertz. If the feedback factor is 0.01, determine the new bandwidth. When looking at this, we know that a bandwidth is a range of frequencies. Then we shall have that range of frequency, and this is F1, this is F2. And we'll be told that the upper cut-off is 200 kilohertz, while the lower cut-off frequency is 50 Hz. This is before the application of negative feedback. With the application of the negative feedback, then we expect that our range of frequency will increase to F1 prime and F2 prime. Taking note that they have increased by these margins here. For the lower frequency margin, therefore, the new lower frequency margin, the new lower frequency margin, F1 prime, will be given by F1 prime, supposed to be the F1 over 1 plus beta VO. 1 plus beta VO. Beta 1 plus beta A. While this results to 50 Hz over 1 plus, the gain was 1,000. The gain was 1,000, and the feedback factor was 0.01, and this results to 4.5 Hz. Limit. Will be given by F2 prime is F2 multiplied by 1 plus beta A. When you look at that, F2 was 200 kilohertz, 200 kilohertz multiplied 1 plus beta is 1,000 times 0.01. When you multiply that, then we shall result in and this is 2200 kilohertz. Therefore, the new bandwidth is given as 4.5 hertz to 2200 kilohertz. We do notice one thing that anytime we are increasing the magnitude in a feedback system, we are going to multiply by a factor A plus beta. Therefore, the observations made are: 1, any reduction in magnitude is given by a factor which is a divisor, i.e. the new value prime is supposed to be given by divided by 1 plus a beta. Where a prime is the new magnitude and is the multiplier of the magnitude. And number 2, for any increase in magnitude, the value is multiplied by a factor